Are your Node.js projects getting harder to manage as they grow? The key to writing scalable and maintainable code lies in interfaces and inheritance, two powerful concepts in object-oriented programming. In this video, we'll break down how to use interfaces to enforce structure and inheritance to reuse code efficiently in TypeScript. Hi, my name is Alex. I'm a senior software engineer with years of experience in JavaScript and Node.js. My goal is to help you become a confident and stress-free developer by increasing your skills and proficiency. Let's get started. We have two classes, car and driver. The driver's drive method accepts a car instance as a parameter and calls drive method on the car instance. But how can we make sure car actually has a drive method? What if we have different types of vehicles that a driver can drive? We will need to ensure each of the vehicles implements drive method. To do that, object-oriented programming has interface feature. Interface in object-oriented sense is a contract. It ensures that a class that implemented have certain shape and certain methods. Since an interface forces a class to have a certain shape, an interface like a class can be used as a type. Let's update our code to introduce an interface. We are going to create iDrivable interface. Interface has a very similar syntax to class with two major differences. Instead of class keyword, you use interface and you don't implement methods. You just define their signature. Some people use naming conventions for interfaces. Like you can see here, I'm calling my interface iDrivable. Capital I is used to denote interface. The next step is to make a class implement an interface. This can simply be done with the word implements on the same line as the class definition. So car class implements iDrivable interface. Now, if we rename drive method on the car to something like go, the TypeScript will complain and tell us that we are incorrectly implementing iDrivable interface. A class can implement multiple interfaces. For example, you can have iStartable interface. Then in your code, you will put that the car implements iDrivable and iStartable interfaces separated by comma. Let's go ahead and update the drive method on the driver class. Now, instead of a car, it can take a vehicle of type iDrivable. Let's do npm run dev to make sure the code is working, and it is. Great. Now, let's create another vehicle that will implement iDrivable interface. We can define a class truck, and it implements iDrivable interface. It also has a property, production date, and a drive method that console logs this make goes error. So the implementation of drive method of a truck class is a bit different than the implementation of drive method on the car class. However, interface doesn't care about the implementation. As soon as the method is implemented on a class, it's all good. Now let's go ahead and instantiate a truck by using new keyword and a class truck and pass it make Ford as a constructor argument. In addition, we will call drive method on a driver instance and pass it the truck. Now you can see two messages in the console. Toyota goes vroom vroom and Ford goes err. That's great. Now you can see the power of interfaces. They allow us to ensure the classes have certain methods and shape, thus enabling us to swap functionality on the fly depending on configuration variables or other conditions. For example, you can have a configuration variable road type, and then depending on the road type, choose in your code if a driver should drive a car or a truck. All right. Now let's take a look at another powerful feature of object-oriented programming, inheritance. But before we do that, if you are learning something new, please hit the like button and subscribe to our channel for more videos like this. As you may have noticed, some code in both car and truck classes is exactly the same. Production date and constructor method. This is not exactly very dry because we are repeating ourselves. To remove the code duplication, we can create a parent class and define repeating code there. Let's define class vehicle and move production date and constructor method from both car and truck into the vehicle class. Now, to inherit the code from the vehicle, both car and truck can extend the vehicle class with a keyword extend, the same way we used keyword implement. As you noticed, you can extend and implement classes at the same time. As I mentioned before, a class can implement multiple interfaces. However, it can only extend one class. Vehicle in our case is called a parent class, and car and truck are children or subclasses. Now it's a good time to talk about visibility. Class members in TypeScript may have three possible visibility modifiers: Public, protected, and private. Public members may be accessed outside of the class instance, whereas private ones cannot. Protected occupies a middle ground between the two, where members can be accessed by instance of the class or subclasses based on that class. In class vehicle, class member production date is public. In order for the class member to be public, it should have a visibility modifier public next to it, or this visibility modifier can be omitted. Basically, anyone can access production date property when it's public. If we add a private visibility modifier to production date, it can only be accessed in vehicle class, and even car and truck classes won't be able to access it. In order to allow car and truck to access the production date property, we can update visibility to protected. With protected visibility modifier, only class itself and its children can access the property. In this example, we changed visibility modifier for a class property. However, the same rule applies to class methods. They can be public, private, or protected. In our case, drive methods on both car and truck are public. Now let's take our code a step further. As you can see, car and truck classes both extend vehicle class and implement iDrivable interface. What if we could combine both parent class and interface? We can actually do that using an abstract class. In most cases, parent classes are not instantiated, and sometimes they can't be instantiated. For that reason, you can make a parent class abstract so no one can instantiate it by mistake. Another feature of an abstract class is that you can also make its methods abstract. To make a method abstract, you need to put an abstract keyword in front of it and not have its implementation. Pretty much like we did in the interfaces. If a method is abstract, the children classes need to implement that method. Let's make vehicle class abstract. We put abstract keyword in front of it. Let's also define an abstract drive method. Now vehicle class is both a parent class and interface. Therefore, we can remove implements iDrivable from both car and truck and only leave extends vehicle. In the drive method of the driver class, we can also change iDrivable type to vehicle type. Also, if we change drive method to go in the car instance, the TypeScript will complain because abstract drive method is not implemented anymore. And there you have it. We have an abstract class with an abstract method that has to be implemented by the subclasses. Before we wrap up, let's talk about construct signatures. There are times when you need to create a function that takes a class directly instead of an instance. For that, you need to use special type with a construct signature. One particular scenario in which you may need to pass in a class itself is a class factory, or a function that generates new instances of classes that are passed in as arguments. Imagine we have a function that generates a new instance of a class. If we pass a car type to the createCar function, it won't work. TypeScript won't compile. Instead of the car type, we need to pass type of the class constructor itself. You have to use type of class name. In our case, type of car. Now everything works. And as usual, let's take it a step further. Since we have a parent class vehicle, it will be nice to have a function that can create both a car and a truck instead of having separate createCar and createTruck functions. Let's define createVehicle function and pass it a vehicle constructor with a type of vehicle the same way we did with a createCar function. However, this code won't work. The TypeScript complains because vehicle is an abstract class and can be instantiated. To make your code work for this scenario, you have to use a type with constructor signature. You can do this by using the new keyword, followed by a syntax similar to that of an arrow function, where the parameter list contains the parameters expected by the constructor and the return type is the class instance this constructor returns. In our case, the parameter expected will be make and the return type will be vehicle. The TypeScript compiler now will correctly compile the code. As you've seen, interfaces and inheritance are powerful tools in object-oriented programming that can help you write cleaner, more flexible code. Once you get the hang of them, you'll be able to design systems that are easier to maintain and extend. They also open the door to more dynamic patterns, like choosing classes at a runtime. But to handle that properly, you'll need to understand generics, a key concept for writing type-safe, reusable code. So stick around and check out the next video on using generics in object-oriented programming.